Hello everyone, we are looking at part 2 of our lesson on midpoints and segment bisectors. This is Unit 1, Day 3 in our notes, and we're looking at the midpoint formula. Now, there's a couple of challenges here, and that's because we're introducing a new way to use the midpoint formula. The traditional way is to use the formula itself to solve the midpoint, and you've done that work before in your Algebra 1 class, but we are going to do that, and then we're going to work in reverse. We're going to use a midpoint to find a missing endpoint, and because that is working backwards, it's going to create some complexities here that will need us to be really organized. So one of the things I really recommend you do is grab a couple extra colors. I'm going to be using all 3 of my colors here, and that's because we want to do one calculation for the x coordinates and one calculation for the y coordinates, and it will really help us to stay organized with these different colors, and I recommend you do the same. To help us do that, we're also going to modify this formula. We're going to just rewrite it in a slightly different manner than how you're used to seeing it, and it will then help us with these types of problems. So this is your midpoint formula. We have 2 endpoints. They're labeled as point A and point B, and to keep them separate, they have these subscripts of 1s and 2. So x sub 1 and x sub 2 are the x-coordinates of the 2 different endpoints. The idea is we're going to add those endpoints together and divide by 2. Now, this is the formula that you're used to seeing, but what does it actually equal? What does it give us? When we do the calculation, what we're doing is we're getting another coordinate point. When we add up the x's and divide by 2, it will give us a number that is also an x-coordinate. And when we add up the numbers of the y-coordinates and divide by 2, it's giving us a number that represents a y-coordinate. But what does this x and y coordinate represent? It represents the midpoint. So this is a more complete version of the midpoint formula. This is how you set it up, and this is your answer. It gives you an x and y coordinate, but of the midpoint, because typically you're trying to find the midpoint. Alright, color number 1, let's start boxing things in. So notice what we did here. When we did our calculations for the x's, the answer to that was found way over here. All right, there's the answer to that calculation. Let's link these two together. I'm going to rewrite that over here on the side. So if we were just adding up the x-coordinates of the endpoints, so it looks like we're starting off the same. But then I'm writing down exactly what that gives us. What does that give us? Well, that gives us the midpoint's x-coordinate. So what we're doing is we're taking this given formula, which has both x's and y's, and we're splitting it up so that we will have 2 formulas. One formula just for the x's, and another formula just for the y's. So take your second color and start boxing things in. This is the calculation that I'm doing for the y-coordinates of the given endpoint, and its answer is found here, which is the y-coordinate of the midpoint. So let's link those together, and so here I am adding up the y-coordinates of the endpoints, y sub 1 plus y sub 2 divided by 2, and that will equal the midpoint's y-coordinate. So you can see we have 2 formulas that we pulled apart from the one traditional midpoint formula. We're just working it separately, one for x's, one for y's. Let's take a look at our examples. Example 3 is a traditional problem. You can see from the diagram even that we could just look at the picture to figure out where the midpoint is, but we'll go ahead and do the math anyway. You could do this in the traditional manner. There would be nothing wrong with that. I just want to show you that this works, and so I'm going to set it up this way. Here we're given the endpoints of segment PR. P is located at -2, 5, and point R is located at 4, 3. So let's find the coordinates of the midpoint. Now if you just read it off of the coordinate grid, you can see that we are 1 unit to the right and 1, 2, 3, 4 units up. So we actually already know the answer is 1 comma 4. But let's see the math work. Okay, so let's find our x-coordinates. I'm going to my first color. Add up the x-coordinates and divide by 2. That means we're adding up the x-coordinates on the ends, and this is very important. It's always the x-coordinates on the ends that you're adding up. So we have a -2. We're adding that with a 4. That'll divide by 2, and remember what it's going to give us is the midpoint's x-coordinate. So this is the variable I'm solving for. So that variable doesn't go away. Here we're going to reduce the fraction on the left-hand side, so that will give us an answer of 1. For the y-coordinates, again we're adding up the y-coordinates and dividing by 2, but it's the y-coordinates of the endpoints. So you can see we have a y-coordinate of 5 and a y-coordinate of 3. So we're adding up the 5 with the 3, dividing by 2, and what does that give us? That gives us the midpoint's y-coordinate. So again, this is the variable, so that doesn't go away. That's the midpoint's y-coordinate. We'll simplify the fractions. So 5 and 3 give us 8. 8 divided by 2 gives us 4. So that's the midpoint's y-coordinate. Those numbers do match what we expected it to be. So the final answer then, the midpoint is located at this coordinate point. The x-coordinate was 1, and the y-coordinate is 4. Now that's a traditional midpoint problem, and like I said, you could have just used the original formula and done just fine, but to help transition to the more complicated problems that we're about to do, I wanted to use this format where we pulled the x's and y's apart from the traditional midpoint formula, and just kind of show you how we're organizing that according to color, because that's what we'll need to really help us with what's coming up next. So let's take a look at example 4. Here it says the midpoint of segment AC is point M, located at 3, 4. One endpoint is point A at 1, 6. Find the coordinates of endpoint C. So this is interesting. We already have the midpoint, but we're going to use the midpoint formula to work backwards to find the missing endpoint. Now again, with a diagram, we already know the answer. We could see those right off of the grid. So let's see what that would turn out to be. Our x-coordinate is 1, 2, 3, 4, 5, and our y-coordinate is 2. Alright, so we already know that the answer will be 5, 2, but let's see how we would work that out with our calculations, so we can then do it with problems that don't have a diagram to give us that aid. So here's the concept. Again, you need to use 2 different colors, one for your x's and one for your y's, and we're going to set this up to solve for the unknown endpoint. That will be our variable we're solving for when we solve for the x's. So let's think about what the formula was that we just said we're using. We're using the formula that says you have to add up the x-coordinates of the endpoints. And you can see in the previous example, I boxed in the x-coordinates of the endpoints. So in the same way, when we get to example 4, I need to add up the x-coordinates on the endpoints. I can't use the midpoint. The endpoint has an x-coordinate of 1, and the endpoint has an unknown x-coordinate of x. That's our variable. Now we know the answer because we saw that off of the picture, but pretend we don't know those numbers just yet. We'll just check our answer at the end. That's the unknown x-coordinate. That's what we have to add together. So it will look like the x-coordinate at one endpoint added with the x-coordinate at the other endpoint, which is x, because that's what we're trying to solve for, all over 2. And remember, what does that give us? It gives us the x-coordinate at the midpoint. So the x-coordinate at the midpoint is 3. Alright, let's just check our setup, make sure we're comfortable with what we just did. In the previous example, we didn't have the x-coordinate at the midpoint because that's what we were trying to find. So that was the variable. But in this example, we do have an x-coordinate at the midpoint. That 3 belongs here. So that's not the variable. The variable is in a new position because what we're trying to find is the endpoint. And our job now is to work with our algebra to isolate this variable and solve for x. Before we do that, let's set up the formula for the y-coordinate. So I'm going to my second color. Remember, the concept is we're adding up the y-coordinates on the endpoints, dividing by 2, and that will give us the answer of the y-coordinate at the middle. So the y-coordinates at the endpoints are 6 and y. Alright, so 6 plus y divided by 2 equals, what does that give us? It gives us the y-coordinate at the middle. The y-coordinate at the middle is 4. So you can see how we have one calculation to do for the x's, one calculation to do for the y's, but notice that they are set up very similarly in that the variable is located in the same location in each set of problem. Alright, now we're going to look at using our algebra to solve for each of these. Starting off with the x's, this is the variable. We have a 1 plus x divided by 2. We don't want that fraction there. We don't want that divided by 2. It's in the way. So our very first step is to multiply both sides of the equation by 2. And on the left-hand side, the 2's cancel out, leaving us with 1 plus x. And on the right-hand side, 3 times 2 is 6. Alright, so that very first step was so that we could get rid of the fraction. Now the fraction is gone. So now we have x with a 1, and we want to remove that 1. We want to move all of the constant terms to the other side, and so now we have x by itself, and there's our answer, 5. We're going through pretty much the exact same sequence of steps to solve for our y-coordinate. Here, as we set up the problem with y, we have a 6 plus y divided by 2 equals 4. Again, the very first thing we want to do is get rid of that fraction, get rid of that divided by 2. So the opposite of that is to multiply both sides by 2. And as we're multiplying both sides by 2, the left-hand side has 2 divided by 2, which cancels out, leaving us with the 6 plus y equals, and then 8 on the right-hand side. So now, let's move the constant terms to the right to isolate the variable. And we get y equals 2. So you can see those numbers do match, so we got the right answer. But we don't stop here. The question is, find the coordinates of endpoint C. To really finish it off, you would say C has these coordinates, and then you'd write them down. Just to be consistent for the colors, I'll write it matching the colors I've used. So C is located at 5, 2. So you can see the answer of 5 came from this leftmost calculation, and the answer of 2 came from this rightmost calculation for the y-coordinates. So that was with the diagram. We could check our answer fairly easily. What if we don't have a diagram? And this is what we'll finish up with today. Here we have this information. We're told that the midpoint of segment AC is located at M, which is at -3, 1. One endpoint is at point A, 7, 6. Find the coordinates of endpoint C. So when I have students taking the quiz on this, oftentimes what they try to do, they don't know how to do the algebra, is they try to plot the points and look to see where that answer is found on the graph. Don't do that. What I mean is, you could do that to check your work, but don't do that as a way to solve the problem, because on the quiz and test, I'm looking at to see if you can solve it algebraically. So we need to use this method here without a diagram. Well, without a graph. I will use a diagram just to help us organize the information. So I'm not plotting points. I am just using this as a diagram to label the information that I have. So I have some picture. I know I have an endpoint called A. I have an endpoint called C, and I have a midpoint called M. And I'm going to take the numbers they give us and just put it on the picture. So again, I'm not actually plotting points. Here the midpoint is located at -3, 1. point A has the values of 7, 6. And the reason why this is helpful so that we remember that C is where the variables are located. We don't know where C is located, point C is located, so that's the x-coordinate that I have to find, that's the y-coordinate I have to find, and now we bring in our colors. So for your first color, we're going to solve for the x-coordinates. How did we do that? We highlighted the x-coordinates on the endpoints. Remember, don't accidentally try to use these two numbers. No, we have to use the values on the endpoints in setting this up. So box in the x-coordinates at the endpoints. That's what we have to add up and divide by 2. So 7 plus x divided by 2. And what does that equal? That equals the x-coordinate at the middle, which is the -3. Alright, let's set it up for the y-coordinates. Go to your second color. Here we have a y-coordinate of 6 and a y-coordinate of y. Those are the y-coordinates at the endpoints. That's what we have to add up and divide by 2. What will that equal? That will equal the y-coordinate in the middle, and that has a value of 1. So now that we've got them set up, we're ready to solve algebraically. Let's do that for x. You can see that we have a 7 plus x divided by 2. Our goal is to get x by itself, so we have to peel away these extra numbers. We start with the fraction. So to undo a divided by 2, we multiply both sides by 2. And on the left-hand side, 2 divided by 2 cancels out, and that leaves us with 7 plus x. On the right-hand side, we multiply to get a result of -6. We want to isolate the variables. We're moving all the constant terms to the other side. I'm subtracting 7 here, and that will give us a result of -13. That's my x-coordinate for the missing endpoint. Now for the y-coordinate, again we have 6 plus y divided by 2. We have to isolate the variable of y. That means we have to peel away these numbers. Let's start by getting rid of that denominator. So we're going to multiply both sides by 2. So on the left-hand side, 2 divided by 2 cancels out. That leaves us with 6 plus y. And then to isolate the variable, move all the constant terms to the other side. And so we have y equals -4. Now again, don't stop here. We want to then label the name of the point, point C, and then bring the x-coordinate and y-coordinate together into an ordered pair. So this is the ordered pair that we have. You separate those numbers with a comma. That's the ordered pair. That's the answer. That's how you format your answer.